Thank you. So, there was supposed to be actually sort of like a best practices from R, but we missed out on that one. But I'll be talking about best practices for Python packages, focusing on sort of how you work with binary Python packages, which is something interesting to us more than some. And it's definitely a little bit more of a challenging problem, but one that I've worked on quite a bit. I'm part of the Scikit-HEP project, which is focusing on building sustainable software using Python. It's funded by the IRIS-HEP grant and other sources, but it's been around since 2016, and really started collecting a lot of different packages from different areas that were focused toward high energy physics. And by roughly 2018 or 2019, somewhere in that range, we ended up with dozens of packages. Several of these needed to build things because we were interested in getting good performance. Collection of these packages were compiled. So that's sort of the diagram that you see here on the right. A lot of the things on the lower shell there that's just above the built-in things like boost histogram and awkward, which is there, are things that needed to be built. And so we've done a lot of work on building up the tooling and on education around how you build and maintain this. And we do this over quite a few different packages. So just to give you a quick view into the Python packaging ecosystem, this is a timeline. So packaging sort of has been changing over the last few years. Originally, there was a utility built into the standard library called distutils, and then that was insufficient. So then setup tools was built to wrap distutils, basically extend it, and the entire thing just became more and more difficult to maintain. And it turns out it's a really terrible idea to put packaging into a standard library, because the standard library doesn't change, and packaging involves the internet, and you're downloading packages from servers and things, and that does change, and building and compilers and all that stuff changes. So around 2015, a PEP, or Python enhancement proposal, was introduced to add to allow the packaging ecosystem to no longer depend on just one special package, as well as special hacks built on top of that, and instead sort of open this up and provide standards that people could write and could follow and build any sorts of systems that they wanted. And this has continued with some other advancements for the last few years, but we're really talking about something that started in 2015, which is packaging is an area where you really have to think about history, because you don't know what people are going to be actually installing your package on. And so a big change is coming up here soon, as well as Python 3.12 will be removing distutils from the standard library. That was proposed in PEP 632 and is going to happen next October. And so this is sort of shaking up the binary building ecosystem, and things are coming along to sort of fill the gap. I'm working with Scikit Build, and I have a grant to work on that over the next 3 years. I'll mention that as we go. So just to show you what Python packaging, if you've seen Python packaging, you've probably seen a lot of examples that are not really ideal, or how we do things in modern times. So this is really what packaging looks like today. So with the 6 lines that you see on the left, not counting the comment there, those 6 lines are enough to create a package you can build. So if you add the 6 lines to a file called pyproject.toml, you will have something you can pip install and work with. A little bit more recommended than that, but that's the bare minimum. You don't need a setup.py, you don't need manifest.in, you don't need setup.config, you don't need all of these old classic files. You don't have to learn different syntaxes and various things. You just need this one, and a toml's fairly standard syntax. It's used in Rust and other places too. So this for pure Python packages has been absolutely fantastic. Things have been moving over, especially to Hatchling. Hatchling has really been Hatchling joined the Python Packaging Authority a few months ago, and it's been getting plugins. Fast API just moved over, I think, yesterday. Lots of things have been moving to this, and it's really, really nice. But if you want binary extensions, currently you still kind of have to fall back into this old setup tools, distutils mess, and that is changing them. One thing that I worked on was rewriting the official Python packaging tutorial to use this system. It was a 6-month project. Most of the 6 months was spent discussing this box that you see here that lets you pick between the backends. But I really wanted that because it shows how much you just need to change those 2 lines. You can just flip the tabs and look. Everything else in the tutorial is identical, and that's really a benefit of this PEP 621 standardized configuration that all the backends can use. So all the rest of the page stays the same, which is really nice. And this is actually everything you need as far as configuration to have a nice project today. Okay, so Setup Tools now supports this, and it's quite nice. But again, this is for pure Python. So this is sort of the components for building a binary package. You need something to create, something you can call in Python. You need something to build this into binaries, and then ideally you distribute binaries, and for that you should have a redistributable wheel builder. And we'll follow this particular path because it's the one I'm involved in. If you're interested, say, in Rust, the PyO3 path there is a really good path as well, and it also has its own builder, which I didn't list there because it's not only specific to Rust. And yeah, but you can mix and match. You can use Motrin, or, well, I guess Motrin is for Python. You can use Meson PY, for example, instead of scikit-build. So PyBind 11 is a header-only pure C++ interface to the CPython API, which happens to work for PyPy as well. And by header only, it's really trivial to add to a project. There's no special build requirements. And by pure C++, I mean that you don't have to add any dependencies. You don't have to run this through a pre-compile phase like Cythonize or Swig or something. And it's not a new language. You don't have to learn how to write a new language. Cython is an example. So this is an example of a very simple PyBind 11 program, and you can see it's just 7 lines there. And that includes the code you're trying to wrap. And I also include the line you would need to compile this, and that will give you something you can import and play with in Python. In Linux, and you can do a slightly different one line for macOS. Here's a slightly more advanced example just to show you that you can do things like names, and you can throw in Lambda functions, you can set properties, you can do all these sort of advanced things quite nicely, simply, and really just learning a little bit more advanced C++, but not learning a new language. And it's got all sorts of really nice features. We've got over 700,000 mentions on GitHub, and we don't require NumPy to build for NumPy, which is fantastic because there's lots of caveats to requiring NumPy if you have to use it at build time. Okay, and we now are running in PyDot. We support WebAssembly. We've done lots of different things with PyBind 11. And just to quickly mention, there's also a package called NanoBind. It's from the original author of PyBind 11. He's still involved with us a bit, but he went and rewrote PyBind 11 again. PyBind 11 itself is a rewrite of Boost Python. This is designed really to do very small, efficient bindings. And it has much higher requirements than PyBind 11. A few tips for best practices for this. Really, I would highly recommend avoiding the CPython API itself. It's going under changes, and it will go under more changes. The faster CPython project, which is fantastic. It's the reason that Python 3.11 is 25% faster on average and 60% in some cases. That is causing API changes, and it will continue to. And using a layer in between that is really helpful. The core devs are suggesting that. A wrapper can help you with that. PyBind 11 and all these things will update for those changes. And your wrapper code is code 2. Don't settle for something that's not ideal. If something is not ideal, improve it. We've gotten involved, and we've been very involved in improving lots of these different things in PyBind 11 to make sure that it would meet our expectations. And then make sure you test pre-releases of Pythons, for example. Now, scikit-build is an example of some way to build it. Now, traditionally, it did this sort of mess where you have setup.py, which is sort of this dist-util setup tools thing. And then scikit-build just sits as one extra layer on top of all of that. So you still need your manifest.in and your setup.config and a pyproject.toml. You still need all of these different files. It's currently being rewritten to be scikit-build core and scikit-build core. And that will just have a PEP 517 builder. And then that interface will be used to provide sort of the class, to replace the classic interface as a setup tools extension. And we're also discussing with other Python packaging authority people, we're discussing writing a PEP to handle general extensions. So a PEP 517 builder could call any extension system you want. We could just tie into an existing builder, which would be very, very nice. And so, and we're trying to sort of modernize this. This was actually part of a grant, SF grant that I'm part of. Rewriting it is the first year. Second year is really focused on some of our collaborators, helping them move over to using scikit-build and using the new scikit-build. Third year is really focused on documentation and training, as well as some tutorials, including some partnerships with the US RSA. And this could include really touching a variety of different packages, not just the scikit-build itself. So a few tips for this area. Definitely watch the space. It's a bit challenging today, but it is getting better. And try to provide binary builds. We'll talk about that in the next slide. But if you provide a binary build, then your user doesn't have to do the build themselves. So they don't have to worry about how you build or not. And try to stay fairly simple just so that you're prepared for changing and updates. If you try to don't add things you don't need if you can avoid it. Just a quick mention on build, which is the build front end. There's lots of examples out there that show this: Python setup.py sdis, Python setup.py bswheel. That doesn't work if you don't have a setup.py. You're just running Python, and it's got all sorts of issues. Like you can't tell it what you depend on if you're just running a raw Python file. So this is replaced by build. So you can use I like using pipex, but you can use whatever you like to use to run Python, and you can use build, and that will build sdists and wheels for you, and it'll activate these build systems. In fact, I show you how you would add this to GitHub Actions in a few lines on the right. I really love that GitHub Actions has pipex as a supported package manager. So CI build wheel is a tool that we at scikit-hep, we actually developed our own set of build scripts called the zero wheel helpers, and then we found we were monitoring the CI build wheel project. We finally decided the remaining things that we needed, we could just add. We did. In fact, we joined with them. And now that's used to do all the builds within scikit-hep. And we actually pushed to get this into the Python Packaging Authority. It was accepted in 2021. And it's done quite well. It has a variety of different features. You can see over on the right, you just need a very simple GitHub Actions workflow, and that will then build all the common wheels that you might need. And it's quite useful. It's not tied to a particular one. Here's a few of the packages that have moved over to using scikit-build over the last, moved over to using CI build wheel over the last year or two, and very happy that we now have quite a few users. And one thing that this has helped, if you've noticed, NumPy's on here, and they released Python 3.11 wheels a few days after the first RC came out of Python. That's never happened before. They've always released after the first full release, and that's because CI build will enable them to do that. So key tips here: redistributable wheels. I would recommend using a system like CI build wheel. In fact, I specifically recommend using CI build wheel. With CI build wheel, I would use the static configuration as much as you can. There are ways to configure this directly in your environment files, but it's better if you do static configuration, because then you're not tied to your CI provider. That stays a very simple script, and you can run things locally. And I highly recommend using Dependabot. One of the reasons we provide an action is that Dependabot can then update that for you, and you can have something just automatically update. That way you don't break right before release. All this comes together in the scikit-hep developer pages, which is something that we built up over the last few years and sort of describing all of our recommended best practices. In fact, we're in talks to try to move this over to make this the scientific Python developer pages. And this includes guides on how you do packaging, both the classic style as well as the simple style. The style guide, which lists all sorts of different things like how you set up type checking and black and placate and pylent and cling format for C++ and various things like that. All this is done through pre-commit, so it's very easy to run them, and they all run in isolated environments, and it's very fast. And as well as lots of other guides, like for how a guide in static typing, things like that. This includes a cookie cutter, which allows you to, once you've learned everything in the scikit developer guidelines, you can then just quickly make a package that follows all of that. And we have a repo review tool, which is both a inline inside the developer pages and runs in WebAssembly, as well as a command line application that you can run. And that will tell you how close you are to following the guidelines. The cookie cutter has 11 different backends. So it'll just ask you what backend, and it can be setup tools, Flit, Hatch. We even support poetry, as well as some of these compiled ones. So you can, this is one of the few cookie cutters that actually produces compiled results. So I've got some links there you can follow. Definitely take a look at our developer guidelines. Take a look at the repo review. It looks like this. You can just type in a repository name and a branch, hit the button, and it will be running Python in your browser, locally in your browser, like in your actual browser, not somewhere else. Downloading this from PyPI, and then giving you a report. This has actually already been used by some other physicists and RSCs to add their own web pages. They've been following this as sort of a guideline, so you can see the try-PyHF page there. So that's been very successful. All right, and that's what I had. And I think my daughter's awake.
Okay, thanks very much, Henry. Do we have any questions? I guess we have another minute or so before we end officially.
I can answer questions in a second. I'm just going to go grab my daughter.
Okay. All right, so I see one question in chat from Dan, which we'll ask when Henry gets back. And one from David that'll be next after that. And maybe we'll call that the end of the virtual workshop for today after those two.
Okay, I'm back.
All right. Yeah, so Henry, so we have one question in chat. I don't know, Dan, if you want to say that, or Henry, you just want to read it?
Okay, so someone asked if this plays well with PyInstaller. Or is there a different stack? That would be a different, I would recommend that usually as a component, depending slightly on what you're targeting. So that would sort of be, so in the, no, don't leave. So in this, so that's sort of showing this diagram, we're showing the different paths through. That would be a different item on the last item. So if you're producing an app, you're not really, if you're also building a wheel, then that would be another, you just have another sort of target here on the top far right. If you're only producing an application, then the packaging story is a little bit different because you're not trying to distribute this as a module you import. But some of the ideas still apply.
Okay, and then Dave.
Thanks, and thank you, Henry, for the talk. Actually, my question was for your daughter. Can you bring her back? No, I'm just kidding.
She just left.
I love everything you're doing. Really appreciate it. I just wanted to ask for, so like I'm developing an extension for PyTorch, and right now their example is use a setup.py in combination with pybind 11. So can you just say a little bit about like where you're at with scikit build, can I test a new version that does not require the setup.py now? And how can people like give you feedback? And
That is coming very soon, but not yet. So I've started working on the rewrite. Technically, I was originally supposed to start, I think basically in September 1st, but I've also started teaching a class. So my percent time allocated is lower than expected. So there is if you know where to look, you can find scikit build core. I'm currently working on getting the wrapping the CMake working right. So I'm working on getting the file API going. So the new one will use the file API to communicate between CMake and the builder, which will allow it to know what it's doing. So the PEP 517 interface is not hooked in yet, or it's not available there yet. But I would expect within, there might be something to start experimenting with within basically probably around a month or two. And at that point, I would love to have people who are interested in just playing around with this and trying it out, and just do it sort of as a test and a PR. Don't actually depend on it quite yet. But I would like to see sort of what people see, and if it looks easy to use. And then I'm going to be I'm going to become, I'll have the curse of expertise at some point, and I need people who don't have that, who aren't cursed with that.
well, I definitely don't have any expertise, so I'll I'll start watching the repo and look for that PR.
All right. Well, thank you again, Henry.